Continuing lesson 31, talking about geometric sequences and series, and looking at example 8a in the notes, find the partial sum. So it says, find the sum of the first four terms of the geometric sequence such that I have the sequence a sub n is equal to 5, 15, 45, dot, 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 all the way up to 5 times 3 to the power of n minus 1. Now, if they're asking me to find the sum of the first four terms, I could legitimately just do that by hand, could I not? Again, s sub 4, adding up the first four terms, is 5 plus 15 plus 45 plus, what would be the next term? Well, if I multiplied by 3 to get from here to here, 3 to get from here to here, let's just do 45 times 3, whatever the heck that happens to be, and then add up these numbers. This will be 20, this will be plus 45, this 45 technically will be just multiplied by 4 if I say I have 1 here and 3 more here. Okay, that gives me 20 times, that's going to be 90, 180. This should be 200, if I'm not mistaken. Again, let me check that one more time. 45 times 2 is 90. 90 times 2, again, okay, is 180. 180 plus 20 is 200. That would be the sum. Now, what if I was given, say, I don't know, 300 terms or 2,000 terms? I don't want to do this lightly. I don't want to do that by hand like this. So let's just make sure we understand how to use that formula. S sub n in terms of the formula is supposed to be equal to a sub 1, 1 minus r to the n, divided by 1 minus r. Okay. My r value we found to be 3 again. What did I multiply by every single time? Is 3. It's also in this formula right here, is 3. What's a sub 1? 5. Let me plug all that stuff in, and I want s sub 4, the first four terms. So, a sub 1 is 5. 1 minus 3 to the power of 4 divided by 1 minus 3. So this is going to be 5 times 3 to the power of 4, 3, 9, 27, 81, so 1 minus 81, divided by a negative 2. Now notice this number on the bottom is negative. This is also going to be negative here. So this is equal to 5 times a negative 80 divided by a negative 2. That's 5 times 40. 5 times 40 is 200. Okay, if I'm not mistaken, let me check that math in my head one more time. Yes, 200. Okay, so the formula does work out either way that we do it. Okay, let's go ahead and look at example 8b now. It says evaluate the finite geometric series. So what's nice about these things is they tell us sometimes what they are. So I know that a series n equals 1 to 17 of something that looks like this, okay, if I have a number to the power of n, I know that this thing is going to be geometric. I'll say that one more time. If I have a number to the power of n, I know it's geometric. Okay? Now, how would I go ahead and do this? Well, there's a number of different ways we could write out all the terms, all 17 of them. That would take some time. Be probably really annoying. What I'm going to do is I'm just going to start by writing out, just to see, to make sure I understand what's going on. When I plug in 1, that thing becomes 0. It's 3/4 of the 0, and that's just going to be 3 times 1. Okay? When I plug in 2, again, plugging in the next term, 2, I get power of 1. So it's 3 times 3 over 4, so that's plus 3 times 3 is 9 over 4. Again, I'm not changing that any more than I have to. When I plug in 3, again, I got to plug in until I get to 17 if I wanted to do this by hand. If I plug in 3, I get 2. That's going to be 9 over 16 times 3. 9 times 3 is 27 over 16. Plus, and I'm going to stop there. I am way too lazy to go through all of those values. So, how do I actually find out what this thing is? Well, this thing is supposed to be equal to s sub what? 17. Okay, I want to add up 1 to 17. I want 17 terms. Okay. So that means that s sub 17 is supposed to be equal to a sub 1, 1 minus r to the power of 17 divided by 1 minus r. What is my r value here? Well, you'll notice on top I'm multiplying by 3. On bottom I'm multiplying by 4. It's this number right here, 3/4. That's my r. What's my first term? Well, it's after I've plugged 1 in, what does that whole number end up being? It ends up being 3. So, I know this is 3 times 1 minus 3/4 to the power of 17 divided by 1 minus 3/4. Okay, there's a number of different ways to work through this basic math. The easiest way is legitimately using a calculator, and let me see if I can get mine out quickly enough here. I don't want to waste any time. There it is. So, 3/4 to the power of 17. I actually want to show this here. Okay, I'm going to have 3 divided by 4 to the power of 17. Now my calculator can do that. I don't know if yours can. Now, in terms of in terms of giving you back a decimal, it's going to give you something like that. Okay, and it probably, I'm not sure if the 84s can do it, but I don't believe that it will give you this fraction at all. Okay, I believe that fraction is too nasty looking for this to do this. So the easiest way to do these problems, okay, is consider the fact that these numbers will not be pretty. I mean, consider it this way. I have 9/4 plus 27 over 16 plus ... until I get to the 17th term. That means I'm going to have 3 to the power of 17 divided by 4 to the power of 17. Those numbers will be very, very nasty. So, in my calculator, I'm going to type exactly as I have here and see if I can come up with a nice answer for this. Okay? So I'm going to have 3 times 1 minus that 3 divided by 4 to the power of 17. Make sure I did that right. I have 3 times the 1 minus and then that. Okay, good. I want to take that and divide it by the 1 minus, in parentheses, 3 divided by 4. Again, this is what my calculator can actually do. It can actually write it out appropriately and then spit back the number it should be. Now, if I approximate that, I'm going to get 11.9. 11.9? That just seems so out of place. I mean, it's not even 12. You would think with 3... plus 9/4, which is something greater than 1. So 3 and then plus another 1. That's at least 4. This one here is greater than 1. That's at least 5. You would think that I would continue on and get something much larger than that. Okay? Is there anything that I did wrong? And I don't believe there is. Okay? I believe this is just the way the problem worked out in terms of the fact that I'm multiplying by 3/4 every time. This number is getting smaller and smaller every time. So eventually 3, again, something 1, something a little bit closer to 1, it's just going to keep getting closer and closer to 1 and eventually not be greater than 1 anymore. It'll be less than 1, which is why 11.9 would make sense. Now, in terms of your answer for this, again, I will not give you one that asks a number this large. But if you can write down this formula at the very least, that's good. The overall answer should be something like this, and again, I will never ask you to do this with numbers this large. That's what the number should actually be. Okay? Again, I will not ever ask you to do a problem like this with this many numbers. Okay? At least not on a test. Now, you'll notice these numbers have gotten progressively worse as we started playing with them. Well, if we look at number 9, okay, formula number 9, if a sub n is a geometric series with r being less than 1, okay, r being less than 1 absolutely, so that means that I'm going to have a fraction. It must be a fraction that's not greater than 1. And the first term is a sub 1, and the sum of the infinite geometric series is this thing right here. That looks a lot nicer than what we had before. Geometric series, in terms of infinite sums, as long as r is less than 1, I can find that sum. Again, as long as my r is absolutely less than 1, I can find the infinite sum. Okay? There is a story to this, and I believe I'm going to make the next video as to how this makes sense and how r being less than 1 actually converges to something that's nice and clear. Okay? Now, evaluate the infinite geometric series. So 12a I'm going to go ahead and do. 12a, we're going to look at the sum as n equals 1 to infinity of a negative 2/3 n minus 1. How do I find this infinite series? Well, the first thing I got to notice is this thing right here is my r value. Again, when I see something to the power of n minus 1 and I start at 1, that's my r value. r is equal to negative 2/3. Is that less than 1 in terms of absolute value? Yes, it's going to be 2/3 is less than 1, so that's perfect. So my r value is negative 2/3. This thing is equal to s sub infinity. And again, that's what I'm going to use for notation, which is also equal to s. Again, that's the notation that we're going to use. This s right here is the same thing as s sub infinity. It's all of the infinite terms added together. What is this going to be? Well, it's supposed to be a sub 1 divided by 1 minus r. Well, my r value is the negative 2/3. Okay, so I'm going to have 1 minus a negative 2/3. Again, the r value is the negative 2/3. I want the r to be absolutely less than 1. What's my a sub 1? Well, for me to find a sub 1, I have to plug 1 in. If I plug 1 in, I get 0 here. So it's negative 2/3 to the power of 0, which is just going to be 1. So this thing is 1 over 1 minus 2/3, or 1 plus 2/3. That's going to give me equal to a 1 over, this is going to be 5/3. And therefore, I going ahead and doing keep flip change to get 3/5. This thing nicely converts to 3/5, okay, which is not a very difficult problem. Let's do 12b. This is probably one of the cooler examples, and it also works for the value of 0.9 repeating. I believe some of you I have shown that 0.9 repeating is equal to 1. Not approximately, is absolutely 100% equal to 1. You can do it with the sequences in series. You can do it with a multitude of other things. What we're going to do, again, is for 12b, come up that every repeating decimal, 0.345, okay, just repeating on the 4-5, is equal to an integer divided by another integer, okay? I want to show that this can be equal to some sort of fraction. That's what I want. Now, how can I do this? Well, the easiest way to do this is start out with 0.3 and add to that 0.045. Notice, if I add these two numbers together, I get 0.345. What is this really? Well, I'm going to go ahead and get rid of that. 0.3454545, and so on and so forth. So I've done this one. I've done those two. So I want plus 0.000, the 3 first zeros, and then the 45. Plus ... This continues on forever. Now, what am I doing here? This 0.3, I'm going to ignore that for a moment. Okay, because it's not actually part of our problem. But from here to here, what am I multiplying by? Well, I'm moving the decimal place over once, twice. So aren't I multiplying by 0.01? Again, if you don't trust me, go ahead and do it in your calculator. Do 0.045 times 0.01. Let me make sure that's right. I'm sorry, 0.045 times 0.01. And that's in scientific notation where I have 4 decimal places. Moving this decimal place 4 times. 1, 2, 3, 4. That is what I'm actually multiplying by. Now let me actually change what that looks like. I'm multiplying by 1/10, 1/100th. I'm multiplying by that value. That's my R value. If you don't trust me, you can go ahead and go to the next one and do the same thing. You will see that that's my R value. Wait a second. That's what I'm adding every time, or I'm multiplying by every time. So then what is this thing going to be? Again, this 0.3, I'm going to hold on to that, but I'm not going to include it in this whole thing. This is my starting position. This is so-called a sub 1. That is a sub 1. And this is supposed to be s sub infinity in some way. Just this piece right here, ignoring that 0.3. So what is this equal to? Well, a sub 1 is 0.045. Divided by 1 minus r, r being this 1 over 100. I take that number and I add the 0.3 to it, and I now have my series all combined together. Now, in my calculator, very carefully, I'm going to go ahead and actually do that math, okay, because I'm too lazy to do that in my head right now. 0.45 divided by 1 minus 1 divided by, let me put that in parentheses, 1 divided by 100. Give it a second. Let me make sure. There we go. Okay. So I'm going to get that decimal representation there. I'm going to add to it 0.3. Oh, that's kind of nice. Although my calculator's an idiot because that's not what I wanted. What did I want? I wanted the fraction. So what I'm going to do to this is I'm going to go ahead and see if there's let's see here. I know that there's a button here for it. And I don't have it here. So what I'm going to have to do for this is I'm going to have to move decimal places around, which is not going to be pretty, but that's okay. Mathematically, when you do that and you send it to a fraction, which you can do, I can't do it on my calculator because I don't remember how the buttons work in my calculator. I'm going to move this decimal place over 1, 2, 3 times. That means I'm going to multiply the bottom and the top by 1,000. Doing so, 1, 2, 3, yes. Okay, will give me what I need to actually find that end result value. Now, because I'm running out of time, I've only got about 10 seconds left. I'm going to stop this. You can, again, do this in your calculator, but I need to see all these steps.